Okay, ladies and gentlemen, here is the 2019 AP number 6. It was a non-calculator question. I don't think all of these types of parts will be on this problem because it's a complex one, but there's some pieces I'm sure are going to be there. We're going to talk about each part there. I've rewritten some of the info. They've told me that F, G, and H are twice differentiable functions. That just means they're all continuous and smooth. And that G of 2 equals H of 2 equals 4. That means G and H meet at the graph 2. So if I graphed them, I don't know what they look like. This could be H. That could be G. But they're going to meet at the same point right there. And they told me that this line is tangent to the graph of G at 2 and H at 2. Now remember, when we have these problems, the challenge level is going to layer itself. It should start out pretty straightforward and easy and get trickier as time goes by. So the first thing asks me to find the derivative of H at 2, or the slope of H at 2. Well, they've already given me that information. They told me that this is the tangent line to H at 2. What's the slope of this line? It's written right there. So the slope at 2 would match the tangent line, which is 2/3. Okay, so the second part asks me to find the derivative. They give me a whole different function. They're asking me to find the derivative of a to the x. So they've written down a thing that's in two parts. It's this piece here, which is u, and this piece here, which is v. So because it is a product, we have the product rule, u prime v plus uv prime. So a prime of x is going to be 9x squared times h of x plus 3x cubed times h prime of x, because this is where they're going to do a lot of, I think. They're going to give you a function, but what's its derivative? Just whatever the derivative of it actually is. And then after I do that, they ask me to find a prime of 2. So I'm going to fill in those numbers. Remember, you guys are using a calculator. It would go like this. It would be 9, 2 squared. H of 2 is 4. We already know that. Plus 3, 2 to the third. And h prime of 2 we found before, which was 2/3. Now, let's say you got it wrong on this part. If you use the number here that you used there, you would end up getting the correct answer as we were going. So this would be 9 times 4, 36 times 4, plus 8 times 3 is 24. I can put that all in the calculator. That would end up with the number 160. Expect something like this, where you have to do a quotient rule with a product rule or quotient rule without the actual numbers inside the function. Okay, so part C has become legendary as one of the harder questions on one of the AP tests. They gave me this function for h of x, and I'll paraphrase what it says. And we use this for every value where x is not equal to 2. It says we can find, it's known that the limit of this can be found using L'Hopital's rule. So if I want to find the limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed. So they're letting me know I could use L'Hopital's rule for this. The only time you can use L'Hopital's rule is when you put in your number and you get 0 over 0. So that's why this problem was so tricky. So let's fill in 2 and see what we get. Put 2 in the top. Oh, sorry, take the derivative of top and bottom first. So it's going to be 2x on top over, now the derivative of the bottom would be the 1 goes away, and the derivative of this piece right here would be 3 f of x, close parentheses, squared, times the derivative of the inside, which is f prime of x. Okay, so basically with this problem, I know if I use L'Hopital's rule, by putting in the 2, I'm going to get 0 over 0. Then I can L'Hopital it and get the derivative to be this. If I originally got 0 over 0, though, what were my values equal to? If I put in the 2, I get 4 minus 4 on top. But what would f of x have to be equal to get 0 on the bottom? F of x would have to be equal to 1, because 1 minus 1 has to give me 0. So that would mean that f of 2 has to be equal to 1. That's how I found that first piece of info out. Kind of tricky, when you think of the problem there. Now now we know what it's going to be. Let's put in 2 into this function right here. Okay, so I'm going to fill in into here what I know to find the limit as x approaches 2. So that's going to be 2 times 2 on top is 4. I'm going to put 2 in the bottom, so it's going to be 3. F of x, f of 2 we know is 1, so it's going to be 3. Is there a negative sign on there? Did I miss a negative sign? Yeah, I missed a negative sign. Sorry about that. Negative 3 times f prime of x. So the question is, what is that going to be equal to? Well, if I'm looking for the limit as x approaches 2, and I know all these functions have the same value of h of x, I know that h of 2 is 4. That means that the value I have to approach for this function has to be 4. And because I know that, I can now find f prime of x by dividing both sides by dividing both sides by negative 3. Let's do it the fast way. Turn this into a fraction. I've cross multiplied, so f prime of x equals 4 over negative 12, which equals negative 1/3. Once again, this was considered one of the harder problems on the AP. So let's take a look at the very last part, which is we know that g of x is continuous, and it's less than h of x between 1 and 3, and that k falls between those two functions. Is k continuous at that particular value? Well, here's what we do know. We know g and h are continuous, because we saw them before. And we know that k falls between them. So the question is, does it end up matching in there? Well, of course it does. So we know that that k of x is continuous. And the question is, why is k of x continuous? Well, because it falls in between those two. And it told us that it was, so what's the reason why? Well, if you need a reason why one thing falls in between the other, the usual answer is going to be the squeeze theorem. Okay, there's one problem. Harder question. Probably all the parts won't be there, but at least we're taking a look at it. Here we go.